When I was asked to talk about flax diseases, I initially thought that I would focus on kind of an overview, a broad approach, try to give you some information on several different things, kind of focusing on those things that you can manage with chemicals, seed treatments or fungicides or whatever. And it became pretty apparent going through some of the data and some of the information we had. I really feel like I should focus on Pasmo. So the rest of this talk, this entire talk is going to be on Pasmo. Before I get into it, a couple comments. So the most devastating disease historically for flax is rust. Rust has been managed really well with genetic resistance for a long time. I know Khalid Rashid he retired recently, the flax pathologist in Canada, and he and I would put different differential lines out into the fields looking for natural Pasmo infections, see if anything was changing in the fields. And it was incredibly rare to actually even see it anymore because the genetic resistance for rust was so good. Sorry, for rust. Fusarium wilt is a problem in flax. It can be a problem in flax. And again, that's really reliant on genetic resistance. And there's a few other things that maybe are not economical most of the time and you can't manage with fungicides. So I'm focusing on Pasmo. So please feel free to ask me questions about other things as well. So Pasmo is caused by Septoria lenticolli. And so I have Septoria highlighted in yellow here because Septoria pathogens tend to act similarly. So other diseases caused by Septoria on other crops, like Septoria on wheat or something, they act similar. They're different species, but they need the same conditions. So they need that water splashing, rain, tend to like moderate to warm temperatures. So Septoria lenticolli is what causes Pasmo. This thing, like other Septorias, is residue borne, so it's on the straw. And like I mentioned, it needs rain. Now, so Pasmo is really widespread in North Dakota. And there were surveys that were done about a decade ago. And it showed up in every county that was producing flax that we surveyed. And so there was about 20 counties surveyed. Yield losses will occur in high yielding environments, and fungicides can help. And so that's the biggest reason I'm focusing on Pasmo. So I want to take you through the disease cycle so you can see how the thing works, and then we'll get into some fungicides. So like many other Septorias, this overwinters in residue. So this is a picture I took in a flax field late in the season. It's straw and it's covered with these little black specks. So the little black specks are reproducing structures of the fungal pathogen, and within these they're going to release spores in the spring. So this is where we're at right now in the season. We have Pasmo, we know we have Pasmo, it overwinters well, and so it is in the residue. Okay, so a little bit further on in the season, you got a crop. Most people are going to see Pasmo like this. So I took this picture in a flax field, bent over looking down into the canopy and spreading it out, and this will be how you first often notice it. So these brown kind of patches on the leaves. So what's going on in the leaves here is you have these discrete lesions, and I'm going to zoom this in here. So this is probably 10 to maybe even 20x. So you can see on the leaf these little brown flecks on this leaf, even this little chlorotic one. That's the first symptom of a lesion, and very quickly when you have this, you will enlarge it, and very quickly it'll also produce more fruiting bodies. So when you get Pasmo started, if you have water, this thing will cycle multiple times. It's going to produce a lot of spores. I mean, this lesion is probably only several days old and it's already having reproduction going on it. Okay, Pasmo, when you see it in the field, tends to look like it comes from the bottom of the plant up. And that's part of that's the canopy density is higher, more moisture on the bottom. Part of that may be closer to residue from a year or two ago. If you follow with me from the right side of your screen to the left, so the right side is closer to the soil line. A lot of these leaves are already dying. By the time you get a little bit further up the canopy, you have these new brown blotches starting to show up. Okay, so Pasmo always looks like it comes from the bottom to the top. This is the same kind of thing a little bit further along. You can see the bottom leaves are all necrotic and the upper leaves are covered with newer lesions. So the issue with Pasmo is that once it gets into the leaves, it's going to go in through the petiole into the stem. And when it gets in the stem, You can see the little remnant of a petiole here. When it gets into the stem, it's going to spread up and down the stem, and it's going to constrict it, and it'll get hard, and it will start interfering with nutrition uptake of the plant, which this is where you get your yield loss from. And you can see, again, these little reproductive structures are in this lesion. So Pasmo, if it does anything, it reproduces a lot, lots of spores. Maybe a week later, you might see these get hard, and they won't spread throughout the whole stem often. You often see these discrete lesions, but they'll get harder and tougher, and the plant will be less productive. Eventually, you might get this barber pole appearance. So where you have infected leaves in the canopy, you'll see lesion after lesion after lesion on the stem. Now, Pasmo can also go up into the seed and the bowl. And so here you can see the reproductive structures again. Pasmo has infected, not a botanist. What is this, Greg? Is this a sepal? Anyways, Pasmo will get right into that, and of course it can impact, seed quality and other things. So one thing that sometimes is important to point out is Pasmo will cause a crop, or can cause a crop, to appear to mature prematurely. And so this is one of our fungicide trials. This is a photo that I took just last year, and you can see some of those. You can see really uneven growth and uneven bolls, and a lot of that is Pasmo. I'm not going to say all of it is, but a lot of that is Pasmo infected plants and plants that have less Pasmo or less infection. And after this, you go back to the residue. So that cycle, the cycle is pretty common, can go pretty fast, and when you have a lot of water, it can cause quite a bit of yield loss. Okay, so general concept about managing Pasmo, we would recommend 3 or more years of rotation, and this goes back to that Septoria type pathogen where it's going to overwinter for a year or 2 in that residue, and so spreading the rotation out is going to help. You might also want to be strategic in where you put your flax fields. Canopy management is important, and that's the same as any other crop that's going to be where the pathogen likes water. So anything that's going to increase that canopy density or increase lodging is going to increase your likelihood of having Pasmo. Weed control is important, but partly because when you have a lot of weeds, you have a lot more favorable microclimates for infection. So resistance, I'm not entirely sure we have Pasmo resistance. I simply don't know. I know there's been breeding efforts in the past, but I don't know how much has made it into commercial flax cultivars. And then fungicides. So this is where we're going to focus. And there's a lot of fungicide data over the years. And what I wanted to do today is try to pull some of that together so you could see essentially the body of work. So you knew where we were at. And we're going to go from some early NDSU stuff in the early 2000s all the way up until stuff that we've done last year. Okay, so earlier in North Dakota, so really 2010 to 2012 and before, there were Pasmo fungicide trials at some of the research extension centers. They were often not necessarily coordinated, so they're looking at one thing or another. Consistently though, headline, so the strobilurin chemistry, proline, which is a triazole, different mode of action, and pencozeb, so like a FRAC-M. Those 3 products or products like them were often tested, and it was simply because those were the ones that were labeled. We did see yield differences in high-yielding, high-disease environments. So that is something that has been consistent for the last couple of decades. So you may remember, if you have visited with Scott Halley when he worked at the Langdon Research Extension Center, you may remember this slide. So this was some work that he did that got quite a lot of attention. I remember being at the Devil's Lake or Lake Region Roundup, and there were a lot of questions about this. So Scott had been able to manage Pasmo pretty well and had been able to produce some pretty high yielding flax. And this is an example of his early work. He had a lot of other things going on here, but there's 2 rates of proline and a rate of headline here. This green bar is a non-treated, and he, using an early bloom and a late bloom application here and a late bloom application here with headline, he was able to increase the yield over 10%, maybe as high as almost 20%. And it was good proof of concept. This is some of the early stuff in North Dakota in a really high yielding environment. If you go back just a little bit further, there were trials that were done in Langdon back until 2002. And I don't know if there were trials prior to that, but Hans Kendall and Greg Endres and others put this together, and this is on the list of resources for you, and I just want to take you through what they did here. So on this left-hand column is the location of the fungicide trial, there where it was conducted. Of course, we have the year here, so 2002 to 2012. And they took data out of multiple fungicide trials and then combined it on this sheet. So what you're looking at here is the yield and test weight of the check. So this is the non-treated control within all these different trials. Okay, so Langdon 2002, the yield was 32 bushels in the check. Okay, this is the yield and the test weight under a headline application. So this was a headline application, 6 ounces, late bloom, and so you can compare them across. So for example, you have Langdon 2002, the check was 32 bushels, with headline it was 34.7, so 2.5 bushel increase. Okay, so what's important here is the average. So you have this 10-year site average, and you can see that the yield of the check is 29 bushels. The yield of the headline application was 35. So over the course of all these trials, different environments, some high yielding, some low yielding, there was about a 6 bushel increase. So that kind of gives you an idea of the presence and in some cases the importance of Pasmo and managing it with an application. Okay, so recently, in fact, just in 2020, there was a publication that came out of Canada, and the publication was pretty intense. There was a lot of things that they did, and I'll show you one data slide and walk you through it. But the main points of what they found was that they looked at fungicide timing, early versus mid-flowering. They found them both effective. Not a lot of difference in the particular timing, and my guess is that's related to environment. Environment tends to play a big role. When is it raining, right? There was a slight improved quality at mid-flowering application. It didn't bear out in all the trials, of course. Fungicide efficacy was important. Headline and Priaxor were the only 2 labeled products that they evaluated, but they did increase yield in high pressure environments, which you might expect. And then fungicide resistance is not identified. So that's part of the reason I'm bringing this up. So Septoria pathogens, over years and years of headline applications or strobilurin applications, they can become resistant to that fungicide. And the Canadians did a good job here looking at that. They did not find anything. And so I would assume the same as in North Dakota, that those chemicals are still effective. Okay, so this is the table I'm going to share with you, and I'm going to try to walk you through this so you can see how this works a little bit better. So in this column, this is the fungicide treatments over the contrast. And so really what I want you to look at are these 4. So you have a control, you have a non-sprayed control, fluxaperoxide, pyraclostrobin, and fluxaperoxide plus pyraclostrobin. So how you would read this is headline here, pyraclostrobin, this is Priaxor here, and this is the SDHI component of Priaxor, which alone you can't get. All right, this is disease severity, and you can see in this group here, you can see disease severity is going down as you have a different treatment. So in this case, these products are managing Pasmo. Here's yield. So this is in kilograms per hectare, which is pretty close to bushels per acre, or pounds per acre, sorry. And again, the point is you can see that the chemicals are managing Pasmo. There's a little information on test weight and oil that I'm not going to get into, but the important part here is that in these 7 site years, so this group of trials here, there were significant differences in diseases and yield. So these are high yielding, high disease environments, and they saw a good response. This group only had disease differences, so there wasn't a yield response. And in this group of trials, there was no differences at all. So although this is, there's kind of a lot of data here, the main point is that in the trials where they had high yield and high disease pressure, they were consistently getting a yield benefit, and the chemicals they used did work. But if you didn't have that, there was no yield benefit. There's about half and half in their trials. So sharing with you what we've done at NDSU in the last 6 years, we've had fungicide trials on the main station on campus every year, and we have been working with the companies trying to get different products and test them. And frankly, there's not a lot labeled for Pasmo, and so we've been looking at other chemicals as well. The fungicide applications here are all made at early bloom, and we're using chemistries from 3 modes of action. And frankly, We don't have high yielding, high disease environments, but we can still separate the products and their management ability. So this is what we've been evaluating, and I'm going to go with you here and try to explain what we've done. So here's the product names, so you'll recognize many of those, and the rates that we've been using. The active ingredient, just to give you the technical name, it's probably not that important. I would say what was more important is the FRAC code. So what mode of action are these different products? The last point I would make is these are the number of observations. So these were not all compared in all the same trial, all the same year. The number of observations gives you a little data on how many times we saw the product in action. So something like Praxor, we've seen a heck of a lot more than Headliner, Elatus, or Muratus Neo. So just keep that in mind as we talk about these. The FRAC code 11 is the strobilurins. And you'll notice right away, every product here except Proline has a strobilurin. And over time, strobilurins have been the most effective product. So a lot of times it's the strobilurin holding the weight of the product. So if you've got Praxor, yes, the fluxoperoxide can help, but it's often the headline that's doing the heavy lifting. Another thing is labels. So I'm showing you the ones here in yellow that are currently labeled. The other ones are not. You know, we're testing products that could be in the future, but just please keep in mind, Elatus, Veltima, Revitec, to the best of my knowledge, they are not labeled. There's another thing here too that we also labeled our approach. So we did evaluate approach, but only 1 year, so I'm not going to share it with you. Delaro, which is a Bayer product, which also contains Proline, and then a strobilurin, that is labeled, and that might be a better choice than Proline alone if you're looking at those products. And then there's a whole bunch of Quadris generics. Okay, so in the trials here, we'll plant them on the main campus, we'll do a bunch of visual ratings, we'll be looking at leaves and stems, and we'll be trying to capture yield data. This is Brian Hansen, a graduate student, former graduate student, now research specialist working with me, and this would be what he would be looking at. So as he's looking down in the canopy, he's going to be measuring visually the level of disease on the leaves and or the stems, depending on the time of the season. So if we take all this data together, I'm going to share with you what we saw on the leaves. So here's the percent of leaves that are turned brown. So the bigger the bar, the more disease. The NTC here is the non-treated control. So we saw leaves turn brown about 65% of the time over the course of these studies. And we saw a reduction of 20 to 30% with all these different chemicals. Okay, so keep in mind, we're not in a high disease environment, but we're still able to look at all these different products, and to some degree, they're all managing Pasmo fairly well. This is the, this disease on leaves. So here's the same slide again with the modes of action put on top of the bars. This is the yield, and so as you can see, we are not in a high yielding environment, and in the non-high yielding environment, we did not see a yield benefit. But if there's water on this, if there's lots of rain, I would expect that you would. The Canadian research and some of the earlier NDSU research in those environments was pretty consistent. So a few just parting comments here. Again, I mentioned the high yield, high disease environments, and managing this generally does pay. Strobilurins are really the chemistry that we would say would be most effective, and there is an additive ability with some of the other premixes, right? So Proline does help, the SDHIs do help. The combinations do work well, which is not always the case in disease management, but because you start to lose some of the amount of the strobilurin in those premixes. But in this case, the strobilurins and all the combination products seem to work really well. The application window is wide, but I would suggest that consider the environment if you're considering making an application. So we did a lot of our stuff at early bloom. The Canadians looked at early and mid bloom. Earlier, NDSU looked at late bloom. That mid bloom application seems to be a good fit for most of it, but again, just consider the environment. So I don't have any more comments prepared, but I'm happy to talk about Pasmo or other diseases, and I'll do the best I can to answer your questions. So thanks to Flax and the organizers and the companies that I've worked with to give us a little product support. And then my last slide is just a map of the NDSU County Extension agents. So they are a very good resource, and depending where you're at, they know quite a lot about flax. A lot of them have more experience with flax than I do, for example.